Hello and welcome back to some more Bitburners. So in the last video, I showed you guys how the get potential targets work, and how we basically compare and sort them from the server with the most revenue yield to the least revenue yield. Hopefully it all made sense so far. If you again, if you have any comments or questions, feel free to leave a comment on the videos, and I'll make sure to try to comment on them or reply to them as soon as I get the chance. But anyway, in today's video, I'm gonna be showing you guys how the get requirements work. So again, this get requirements is basically the core part of the key to making all of this launch fleets work. So without this, there wouldn't be launch fleets and or coordinated attacks. So let's jump into this get requirements function. Basically, what this get requirements function does is it basically just retrieves the attack requirements for I guess a certain server. So we retrieve three things: the strategy, the delay, and then the maximum threads that we can run for that server. The strategy basically determines whether or not we're growing the server, weakening the server, or we're stealing money from the server. The delays basically just make sure that our strategy is executed in the most optimal fashion. So it basically just executes all the I guess sequence of actions and then have a 50 millisecond delay between all of them. So if you've seen the attack delay, if you've seen the attack delay variable here, basically you can tweak this. So if you want the servers to I guess the actions to be separated by 10 milliseconds or something like that, then you can do that. You can tweak this. But please note that this is subject to, I guess, JavaScript. Just because you execute the attacks by 10 milliseconds doesn't mean that it's going to execute exactly at 10 milliseconds. So that's why I just set 50 milliseconds because it's sort of like the sweet number. So let's jump into the get strategy first. So retrieving strategy, basically it works similar to how we do the gimme money script. This get strategy basically looks at the server and then looks at the money and then security threshold. So again, the money threshold basically determines how much I guess how much money the server needs to store before we can actually hack it. The security determines the minimum level of security that our server needs, so that our hacking chance is increased quite a lot. So every single server has its own level of security, and then the chance of stealing money from the server is determined by the level of security. So we just want to make sure that it's as small as possible. And then we construct our result object here, which is gonna return the type, so which is just the strategy name, the sequence. So this just a bunch of actions that we're gonna execute, which is represented by symbols. And then the allocation, so the percent allocation. So if let's say that the number of threads that we have available on our server doesn't meet the I guess the required number of threads to launch the attack effectively for a specific server, then we want to I guess use that total amount and then just reallocate some sort of ratio for those. And then here's some of the conditions here. So if the server security level is greater than the security threshold, so it means that the server is still very strong, then we want to flog the server. It means we want to weaken the server. Basically, the action sequence that we launch for the flog strategy is allocating 30% of the threads to grow actions, and then 70% of the threads to weaken actions. And what this one will do is that it's gonna put money into the server whilst also weakening it, because there's a lot more threads that's running the weaken script. Feel free to tweak this. This isn't final, but as long as the numbers between in this array is equal to 1, then the script should work perfectly. And then the next condition that we do is we check whether or not we have enough money in our server. And then if we don't have enough money, then we nourish the server. It means that we grow the server. So similar to, I guess, the weaken script here, basically the sequence is also grow and weaken, but the allocation is different. So we have much more grow scripts than the weaken scripts, and the reason why it's somewhat equal is because the grow commands also adds in some security. So I guess the weaken threads is there to counteract some of those security increase. So if we have, I guess, the minimal security and quite a lot of money in our server, then that's when we plunder the server. So that means we hack the server. And how plunder works is that we execute the hack, weaken, and grow weaken sequence. Um, so if you wanna get the reason why we execute the sequence for, I guess, hacking the server and not just having lots of hacks, I highly recommend going back to episode 5 because that explains I guess the problem with allocating every single one of your scripts to a single server, and also the sequence that the actions need to be executed in. So we just allocate an equal amount for those, and then we just return the result. So by the end of it, we have the strategy name, the sequence of actions that we're gonna be executing for when attacking a server, and then a recommended allocation. So in to handle the scenario where we don't have enough threads to execute the attack successfully. Alright, so moving down to the next one, so get delays for action sequence. So this one's a very confusing one. It's written very very small, but it like the logic of it is very much complicated. But just to cover how the script works from a very high level, because I already explained this in depth. So if you want like a detailed explanation of how it works, feel free to go back to episode 7 where I explain this a little bit more. But basically, how the algorithm works is that given a list of sequence, the first thing we do is that we first create the execution lines. So each of these lines represent when each action will finish. So grow, weaken, hack, weaken, for example. So grow will finish here, hack, weaken will finish here, hack will finish here, and then weaken will finish here. And these lines are arbitrary. So these are like starting from 0 plus the delay. So 50 plus another delay, 100, that sort of thing. So that's what the execution lines represent. And then for every single execution line, we then, I guess, draw out every single action. So we want to make sure that the action finishes directly on the line here. So when it needs to finish, so the execution line. And basically how we do that is we subtract the x coordinate of the line by the width of the action itself. So the delay or the timing it takes it to execute that action. So we grab the x coordinate and then we take away the width, and then we do that for every single one. And then after reallocate, I guess finding the starting points of each one of these actions, then we grab the minimum. So grab the minimum out of every single one of these actions, which one starts first, and then grab the x coordinate for that. And then from using this x coordinate, we then calculate when these actions will, the distance between this x coordinate, the smallest x coordinate, and when the action starts to calculate the delays. So yeah, so that's how it works from a very high level perspective. So looking at the code, basically we grab the time it takes to execute the hack, weaken, and grow commands using the formulas.exe, and then we basically just map it to some sort of object that maps the sequence letter to the timing. And then the first thing we do is we define, I guess, an arbitrary set of values representing when the action will end. So we basically create go through every single one of the items in our sequence, and then we just increment it by the attack delay. Um, and then after that, after defining the base times, we then try to find when each of the actions will start. So we go through the sequence again, and then we basically just grab the timing for it, the time it takes to execute that action, and then we grab the base time, and then we take away the execution time. And then after calculating when every single action will start, we then try to find the smallest x coordinate. So we just use the min function. And then from using this smallest x coordinate, we then calculate the delays by subtracting the execution start and when the action will start. So yeah, so by the end of it, you're gonna have an array containing a list of delays for every single action for your strategy. And then the last thing we do is we calculate the maximum number of threads that we're gonna allocate for the server. And the reason why we want to do this is because we wanna maximize the allocation of our resources to only assign the threads that's needed. So how this get max threads work is first we grab obviously the maximum thresholds for the money and then security, and then we also grab the current money. So for growth calculations, so calculating the growth threads, basically if there's no money in the server, then we want to assign just a single thread to it just to put some cash into it. Otherwise, we calculate the grow multiplier. So basically, this one's asking how much do we need to multiply the current money to reach this money threshold. And then if there's at least one of them, like a growth multiplier 1, then we wanna use the growth analyze function to calculate the number of threads required to grow our current money to equal to the money threshold. For weaken, this one's somewhat straightforward. So this weaken effect basically symbolizes how much a single thread could reduce our level of security. From this weaken effect, we then calculate how much threads we need to decrease the security to the level that we need. And then lastly, the hack calculations. So what this hack effect does is that it calculates the percentage of the server's money using a single thread. So when you run a hack, how much money will a single thread, uh, hacking thread retrieve from the server? And then we then calculate the I guess the amount of money taken from the current money using that single thread. And then from the hack taken, we then calculate the number of threads we need to reach the money threshold. I know this is kind of confusing, but it's definitely quite a lot of maths. I have a feeling that there's probably much more optimal ways to calculate these threads, but this works for now. Um, and then down here we then do some checks, and the reason why we do these checks is because these analyze functions, they actually sometimes return infinity, mainly because of bugs within the code. So we just want to make sure that none of them will be infinity, just so that we don't allocate the servers incorrectly. And then after calculating all the threads, we then just return them into one big object with the grow threads, weaken threads, hack threads, and then the total amount of threads. And then after retrieving the strategy, the delay and max threads, we then just put all of that together into a single object. So yes, that's about it. I feel like this video is kind of information heavy, but we're now past the most confusing part of the launch fleet script. So in the next video, I'm going to be showing you guys how we use these requirements to assemble our fleets. So I'll see you guys in the next one.